Okay, we're going to finish up part 2 here, picking back up where we left off. Okay, so we did one example here. We're going to do a couple more examples of these. Finish up this section. So we got, what about if we had y equals, let's say 2, and let's do absolute value of negative x minus 1, plus 3. We want to sketch this. So first we got to identify what transformations we have. So we have a vertical stretch by 2. The negative inside is going to be a y-axis reflection. Subtracting 1 inside moves the graph to the right 1 unit, and adding 3 outside is going to move the graph up 3 units. So the order, we got to do reflection first, vertical stretch second, right and up at the end. So our starting graph is going to look like absolute value. So we get absolute value, and absolute value has the point 1, 1 and negative 1, 1 on it. First we do a y-axis reflection, which when you reflect this about itself, the right-hand side reflects over to the left-hand side, and the left-hand side reflects back to the right-hand side. So the graph basically lines back up with itself. Next we do a vertical stretch by 2, which is going to say double the vertical distance of your function. So we'll get a much narrower absolute value V shape. So this is where we're at after the vertical stretch. And then we're going to move that narrower V shape. We're going to move it right 1 and up 3. And this is where the origin goes. So the other 2 points that we went through, it's over 1, up 2, over 1, and up 2. And this makes your narrower absolute value V shape. One that they like to give us on tests is if we look at the transformation, so we have negative a f of negative b times x plus c plus d. This does x-axis reflection. This a here will do vertical stretch shrink. The negative in here will do a y-axis reflection. The b here will do a horizontal stretch shrink. The c out here, this is going to move stuff left and right. And the d out here will move things up and down. So one that they like to give is, if you notice, like whenever we did the horizontal stretch or the y-axis reflection, this number here on the inside is multiplied to the shift part with parentheses. So what they like to give you is they like to give you some types that are like, say we had negative 2x plus 10 cubed minus 1. And this looks like this would be a horizontal, or sorry, a y-axis reflection, horizontal shrink by a half, and a shift to the right 10. The problem is the negative b here has been distributed in this problem. So when we want to graph this, what we have to do is we have to factor out the negative 2 first. Because without that negative 2 factored, the positive 10 is not just a shift. It's a shift mixed with a y-axis reflection and a horizontal shrink. So in this one, now that we've got it down to this point, we say, okay, this is a y-axis reflection. This right here is a horizontal shrink by a half. This right here says I'm going to the right 5. And that out there says I'm moving down 1 unit. So reflections first, shrink second, right 5/3, down 1/4. So if we graph this, we start with the cubic graph, which looks like this. Got the point -1, and the point +1 on it. So first we do a y-axis reflection. So this right-hand part reflects and becomes the new left-hand part. The left-hand part down here reflects and becomes the new right-hand part. Next we do a horizontal shrink by 1/2, which means take the x value of these points and pull them into 1/2 of where they're supposed to be. And that gets us our new narrower graph that's had its horizontal distances crunched in by 1/2. Okay, so this is after the reflection. This is after the shrink. So we're going to take that narrower cubic. We're going to move it right 5. And we're going to move it down 1. That's where the new origin goes. And then we draw our narrower cubic graph in. So two other things, last two examples we're going to do from section 2.7. One of them says, for this example, suppose we had an absolute value graph that looked like this. So it was here. And it opens downwards, and the spacing on this point is, if you go down 2 and go to the right 1, you get where the graph is. If we move down 2, we go to the left 1, we get where the graph is. And we want to write the equation for that graph. So we know the base function is going to be absolute value. Since it's opening downwards, we know there was an x-axis reflection. Since the spacing here, instead of this points being just 1 down and 1 to the right, or 1 down, 1 to the left, since it's 2, that says a vertical stretch. Excuse me. It says a vertical stretch by 2 has happened. And then it's moved up 2 units, so that means there's a shift up 2. So we have to put this all together. So we'll say, okay, the equation will be y equals x-axis reflection says there's a negative outside of absolute value. Vertical stretch by 2 is also outside of absolute value. And the stretch up by 2, that would be adding 2 outside. So this right here would be my equation corresponding to this graph. So this is kind of working in reverse, where you start with the graph and work your way backwards till you get with the equation. Last example we need to do here is, we'll say, consider the transformation y equals -h of 1/4 x plus 2. And so we got all this right here. And we want to go through, and what we want to do is we're going to say, where is the point? Let's say x value 1, y value 2, sent, and I guess this point here, it's understood this is on the graph y equals h of x, sent by the transformation. So basically what we do is we start with the point 1, 2, so x value 1, y value 2, and we're just going to follow the transformations applied to this around, and where the point ends up, that'll be our answer. So we started with 1, 2. So we got a point there at 1, 2. We got an x-axis reflection. This inside here is horizontal stretch by 4. Inside works reverse, so it's a stretch instead of a shrink. Then out here we got up by 2. So reflection first, stretch second, up 2 at the end. So we do an x-axis reflection. So this point has x value 1, it goes down and has a y value down here of -2 now because we reflected about the x-axis. Next, we're supposed to do a horizontal stretch by 4. So that means quadruple the horizontal distance. The horizontal distance is currently 1. If I quadruple it, that means multiply it by 4. So now my point's way over here at x value 4, y value 2. The final step is we're supposed to go back up 2. So we go up 1, 2. So x value 4, y value 0. This is the answer. This is where the point ends up. So the coordinates of where the point ended up was x value 4, y value 0. And that's how we viewed the point being sent along by the transformation. So we're going to stop there, and that wraps up section 2.7.